recording for those people. So, stem and leaf diagram. I picked out certain words that you need to pay attention to. All right. We need to know what they're used for. So that's why I've put here, it's just a way of organising data, grouping it, okay, which you've done before. So you've grouped data using tally charts before, remember doing that? So you tally it, you add up the tallies and so on. Okay. Now the big difference between a stem and leaf diagram and maybe when you've turned a tally chart into a frequency chart, meaning bar chart, is that you don't lose the detail. You know what all the numbers are. So the bar chart, you know how many might be within a particular group, but you don't know where they are in the group. I had a question, which is, do you guys all know how to work out the modal class from a bar chart? Do you know what that means? So let me, because this is being videoed, you can always sort of do the rest of your notes. So if I said to you, modal class, what does that mean?
This is like when we have a lot of data, we have like, for example, from 0 to 5, and from 5 to 10.
No, that's a class. You've got the class bit,
like
right?
Greater or equal to.
So that's interval. So what you're saying is when it's 0 to 5, for instance, like that. That is a class, but what does the modal class mean, Shradika?
It's the unit, the number with the most, unit number with the most,
Should we just say in
with
it?
the most numbers.
Yeah, okay. Another way, the modal is just another way of saying mode, yeah? So the mode is just the most popular. So when we talk modal class, we talk about the interval with the most in it. So in a bar chart, that represents itself as the highest bar. Okay, so the highest bar is the modal class. Alright? Do you all know how to find the median? Median is the middle value. Okay. Right, so you have to know how many you've got in total, and then you can find the middle value. Right. Do you all know how to do that from a bar chart? No? So that's something we should go through. It'll work. You'll see the difference between it and a stem and leaf. And then the mean. You'll remember how to calculate a mean. Or I don't like, you can't use the word average to represent the mean. Because?
Adding all the numbers divided by the mean.
Yeah, well, that's how you do it. But why can't you use the word average instead of mean, Ricky?
This average usually excludes the numbers.
No, that's not why. Okay.
Because all of them are averages?
Yeah. The mean, the median, the mode, they're all averages. They're types of average. Okay. But the mean is add up all the numbers. Okay. And then you divide by the number of numbers. Now this would be written like, new notation for you, x bar is the mean of whatever values, that's what it means, the mean of the x values. Okay. You add up the sum of all the x values. Okay. And you divide by the sum of the frequency. You recognise that sum of symbol?
Nope.
Those of you that have done Excel computing, which must be all of you know, at some point you've seen the sum of symbol is a sigma. It's the same thing, that's what it means. Okay. So what we need to be able to do, we need to be able to calculate mean, median, mode from all of our charts, from bar charts, from stem and leaf. Well, really just bar charts, histogram, stem and leaf. All right. So we'll start now with talking through again our stem and leaf diagrams. Okay. So stem and leaf. What we're going to do is we're going to look at question 5 on page 115. Okay, and we're going to go through how you put that data into a stem and leaf diagram to get it organised. All right, so I've gone through a couple of things. So a stem and leaf diagram has obviously a stem and it has leaves. Okay? My line's gone quicker, hasn't it? Now, the thing is, you have to tell me, or tell the reader, the person that is trying to interpret your diagram, what I mean by the stem and leaf. So obviously you need to know about that. So if we look at this data, what is the range of the data? Do you know what I mean by range? So it's the maximum to minimum. So what is the maximum value in that data set? What do you reckon? 95. Any advance on 95? Maximum's 95. What's the minimum value? 29. Now here's the thing. In this data, there are certain things that are repeated quite a lot. And the things that are repeated quite a lot are the 10s. So there are lots of 60s, there are lots of 80s and things. So what we do is we look at our data and we set our stem up as the thing that gets repeated. So in this case, I've got tens and units, right? So the stem will be my tens, okay? My leaves will be my units. So I need to go, right, from minimum to maximum. So I know 29, so my first stem number needs to be a 2 to give me the 20s. And then I do 3 for 30s, 4, 5, 6, 7, 8, and 9. Okay? And over here, on my key, I'm going to write something. So I'm going to start, here's a little example of the stem, and here's a number that's in the stem. Okay? Now, on the leaf side, that's going to be the units. So in my key over here, this will be my key, I'm going to write 35 means 35, and that's what it does mean. All right? Because it can be something different. You can put decimal values in, okay, where the stem is the whole part and the leaves are the decimal part. Okay, you could put hundreds and tens, whatever you want to do, but as long as you state that in a key. Right? Now, I wrote in the thing over here, to save time, although you might disagree, the save time, but it does, but definitely decrease the probability of making a mistake, the stem and leaf diagram is done twice. Second time is to put things in order. So now I've determined my stem. All I'm going to do is I'm going to go through the list and put things in the right way. So I'm going to go through, you're going to go through. So this line is for my 90s, so I'm going to put a 92 for the first number. I'm just going to go through along the line. And I've got 29. Now I've got to make sure the first numbers are all lined up. So 78, 67. Now here's the question. I've just done a 67. Now I've got to put a 68 in. What do I do?
Put the 8 on like
exact. So I've just put an 8 next to the 7, right? There's no need to do any other separating because I know that that 7 is not a 7, it's a 67. And this 8 is not an 8, it's a 68. And if you go through, making sure everything's lined up nicely, you can put all of those numbers in. So I'll let you do that as well. Okay guys, see some people, what you've done, which is fine, it's up to you, you've looked at the data and you've tried to put it immediately in order. So you've gone through and picked all the 60s out and put it immediately in order. That is one way of doing it, but I'm just here to say that that's the most likely way of missing numbers, making mistakes, and it actually takes longer. Because what I do now is once I've got it in that way, not in any order, I rewrite it, but each line in order. Because I've grouped them into their tens, but now all I have to do, you see, well that one's done, it's a 9. This one is very easy with 8, 9. And then I've got 3, 4, and 7. So the actual ordering of it becomes a lot quicker. Okay? So when it gets a bit longer, yeah, a bit more winded. So 1, 3, 5, 6, 6, 8, 9, and so on. And we go through and we order it. Okay? Now that is a much more secure, should I say, way of doing it rather than going, oh, I missed that one, that's got to go right in the middle of my line. So what do? Do you cram it in? Do you just redraw it in the middle of your line? Or no? Because what's the problem with just cramming a number in?
It won't line up with the
Exactly. It must be lined up. So you can't just stick a number in that you forgot. Okay? So we have to have them lined up. The reason is because we want to use the shape afterwards. So we have our stem and leaf diagram. Now everything in order. Okay. Now again, in an exam, you're probably not going to have to do a whole stem and leaf diagram. So you see, it does take some time. Probably not. Probably not. Not definitely. But what's actually important now, what you will definitely have to do in an exam, is go from this stem and leaf diagram and be able to pick out certain values. Right? So, what we need to be able to do is find the median value. Okay, so let's have a discuss. How do we find the median value for a data set? Yep.
Do we count the amount of numbers that there are?
Yeah, so we count the amount of numbers that there are. So how many numbers were there? It's probably easier from the table. From 50. Okay. So if there are 50 numbers, how do you find which one is the middle number? No. I understand why, but it's not the 25th number. How did you find the 25th number? Okay, think about that then. It is half. If you split 50 in two, you get 25 in each group. Is that the middle? Ella?
Isn't it like halfway between the 25 and the 26?
It is. Okay, so when you've got an even number of numbers, if you split it into two groups of 25, what's the middle of two groups of 25? A gap. So you have to take the 25th number from the first group and the first number from the second group, which is the 26th. So we have to find the, what do we say, the mean of the 25th and 26th numbers. So then I just have to count them through. So however you want to do it. So count in order, smallest to largest. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 60, 70, 80, 90, 20, 21, 22, 23, 24, 25, and 26. Okay?
67 plus that.
Do you agree? Have I missed any numbers out? So we reckon the median would be 67.5. Okay? Because halfway between those two numbers. Right. Common mistakes that people make at this stage. What do they write instead of 67.5? Monica? 7.5. Yeah, they forget the 6 at the end means 67. They forget what it means. Okay? We have to also find the mode. Pardon? Will be the... Okay, so if I wanted a modal class, you would say the 60s. From 60 to 69, yeah? So we'll write that. So modal class, if we had it in a different form, would be 60. So I'll put X to, I'm going to say 69. I'm going to put an interval notation. I can put equal on because there is no above 69 in this case, so I can do equal. But that's not the mode. So, like I said, with the stem and leaf diagram, we can still be detailed. So we can give an actual mode rather than a group that is the mode. So what is the mode? Sorry, what? Ella?
4 different ones.
4 different ones. So what would you say the modes could be?
56.
56.
64, 80, and
64, 80, and 89. Yeah. There are 4 different modes in this case. Right? Which would lead us to state something on an analysis sense that actually the mode is not worth looking at, is it? If you've got 4 different modes spread out through the data like that. Some people, again, what do you think a common mistake for mode would be? Ricky?
Picking out the first one they see and then the rest.
No, actually. No, they wouldn't just go, no, they don't tend to do that. There's something else that happens, actually, on the mistake.
They ignore that side and just think about
Yeah.
all the 9s or...
Yeah, exactly what I was thinking. They would look at this side of the diagram and just add up how many 9s there are. And there are loads of 9s. You know, I've got 1, 2, 3, 4, 5, 6, 7, 8 9s. Okay, how many 6s do I have, and so on. And they would just write, oh, the 9 is the mode. And it's not true. That 6 there does not go with that 6 or that 6. It's not a 6, it's a 56. Okay, but you guys are, you know, are not making these mistakes, which is good. So we've got 4 modes: 56, 64, 80, and 89. So we might not bother. Okay, what about what's called the Interquartile Range, IQR, Interquartile Range. Does anyone know what the Interquartile Range is?
Would be like 25th by percentage on the quarter value.
Yeah, exactly. Do you know another name for the median? The what? Not the middle term. This median is actually the 50th percentile. So halfway, 50%. So the interquartile range, okay, you find 75% and you subtract the 25th percentile. Okay? 75th percent is called the upper quartile. Sorry, quartile, and 25th, the lower quartile. Right, so we have to do a subtraction. So it's kind of like just finding the median of the lower half and the median of the bottom half. so we've got, because of our median, we know we've got 25 and 25, top and bottom. So here was our halfway point. So I basically got to find the median of the lower 25. So where would that be? Which number? No, actually, it wouldn't be. Because the difference is 50 could be divided by 2 and make 25 and 25. 25, on the other hand, can't be. So it would be the 13th number. Because if you take the 13th number, how many is on either side of it? 12 and 12. Okay? So we need the 13th number from top and from bottom. Okay? So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Okay? So we're looking upper quartile is 58. Now just to check, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got it right. And the same from the other end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here. Okay? So that would be, so the upper quartile would be 80, subtract 58, which the interquartile range would be 22. That's the interquartile range. Okay.
What would the interquartile range be used for?
Very good question. What would it be used for? So I'm just going to mark the interquartile range. Okay.
Why is it 75% and 25%?
Right, well if you think about it, so it's those ones I've put a purple above, how much of your data is included in the interquartile range? Pardon? 50% of your data, half of it, right? Now what you've taken is the middle 50% of the data, half the data. Now it just so happens that normally, statistically, that's where all the interesting stuff happens. The middle 50% of the data. Because what happens in the first 25% or the last 25%? You tend to get what's called, anyone know? Any words will do. There's lots. Anomalies. You get anomalies. You get things called outliers in your data. You get anomalies happen. You know, when you look at the school, what's the general result of the school? What we like as a school, right? Now, you would pick the middle 50% of students' results and go, that's basically what we're like. There will always be the odd brainiac, and there will always be the person that doesn't quite do it because they don't work or something happens. But they are extremes, potentially. And how do we get rid of the extremes so they don't affect our results, either positively or negatively? We take the middle 50%. All right? So it's an important thing to look at. All right? So that's why we need to be able to state the interquartile range. All right? So that's basically it. Let's have a look what else we need to be able to do. So we just answer these questions then. What percentage of the students scored 80 or more for the test? So 80 or more for the test is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
28%.
So 14 out of the 50 is 28%. Good, nice easy one when they give you 50s like that. Right, 80 or more. Right. Would that result change if it said more than 80? This vocabulary. So how would it change if it was more than 80?
80 wouldn't be included.
80 would not be included, so it would drop by those three. So it would only be 11, so therefore 22%. So there's beware, 80 or more than 80. So many people, when it says more than 80, go, is 80 included there? You know, fair enough question, but no, it's not. Now, so the thing then is, what percentage of students scored less than 50? So that covers it then. Less than 50. So we're looking at only these ones, aren't we?
12%.
So 3, 4, 5, 6. So 6 out of the 50, which makes 12%. Okay?